December 18th, 1944, 1,423 hours. A snow-covered field 3 kilometers east of Stavelot, Belgium. Oberscharführer Kurt Meyer sat in the commander's cupola of his Panther Ausf. G. Scanning the rolling terrain through Zeiss optics that could resolve a man-sized target at 2,000 meters. His tank, all 45 tons of sloped armor, and the superlative 75mm Quake 42 gun, represented the pinnacle of German armored engineering, a weapon system so technically sophisticated that Allied intelligence had devoted entire reports to understanding how it could be defeated. Meyer's crew had been together for 8 months, veterans of the retreat from France who knew their machine intimately and had learned to compensate for its temperamental transmission and chronic fuel hunger. They were hunting American armor that reconnaissance had reported in the area. Sherman's, almost certainly, the ubiquitous American medium tank that German crews had learned to respect but not fear. A Panther could kill a Sherman at ranges where the Sherman couldn't effectively return fire. The mathematics favored the German. Meyer allowed himself a cold smile as his driver reported the engine warm and ready. Then his gunner spoke, his voice tight. "Panzer. Fast. 11 o'clock. Moving. Mein Gott. Moving very fast." What Oberscharführer Meyer saw through his optics in the next 3 seconds would invalidate every assumption he'd made about American armored doctrine and reveal a truth that German tank commanders across the Western Front were learning with mounting horror. The Americans had stopped trying to build a better tank. Instead, they had built something faster, cheaper, and produced in such overwhelming numbers that tactical superiority became strategically irrelevant. The vehicle racing across Meyer's field of view wasn't a Sherman. It was lower, sleeker, and moving at a speed that seemed physically impossible for a tracked vehicle accelerating across frozen ground at nearly 55 miles per hour, a velocity that exceeded most German tanks' maximum road speed by almost double. This was the M18 Hellcat, an American tank destroyer that had abandoned the entire paradigm of armored warfare as German engineers understood it. It wasn't built to slug it out in armor-on-armor duels. It was built to appear, kill, and vanish before the enemy could react. And it was being produced at a rate of 100 per month in a factory that would manufacture 2,507 of them before production ended, more tank destroyers than Germany would build of all types in the entire war. Meyer's gunner was tracking the target, but the traverse mechanism couldn't keep up with a vehicle moving that fast at that range. Before he could fire, the Hellcat had disappeared behind a tree line, leaving Meyer with the unsettling realization that his technically superior Panther had just been rendered tactically obsolete by an opponent who refused to fight on German terms. What Meyer couldn't know, watching that Hellcat vanish in a spray of snow and frozen earth, was that he was witnessing the culmination of a fundamental philosophical divergence in how the United States and Germany approached armored warfare. The Germans had pursued perfection, heavily armored, powerfully armed tanks, built with precision engineering and crewed by extensively trained specialists who understood their vehicles as complex weapon systems requiring skill to employ effectively. The Americans had pursued volume, adequate armor, adequate guns, exceptional reliability, and production numbers so vast that individual vehicle losses became statistical noise rather than tactical setbacks. The M18 Hellcat represented this philosophy taken to its logical extreme. Strip away every ounce of unnecessary armor. Install the most powerful engine available. Arm it with a gun that could kill any German tank from the side or rear, and build it so quickly and so cheaply that you could afford to lose half of them and still have numerical superiority. This wasn't just a different approach to tank design. It was a different theory of how industrial warfare functioned. And that theory was about to bury German armored forces under an avalanche of speed, numbers, and the terrifying realization that you cannot win a war of attrition against an enemy who can replace losses 10 times faster than you can inflict them. The M18 Hellcat specifications read like a deliberate rejection of German tank design philosophy. It weighed 17.7 tons, less than half the weight of Meyer's Panther and barely a quarter the weight of a Tiger I. Its armor maxed out at 25 mm on the front glacis, compared to the Panther's 80 mm of sloped armor, or the Tiger's 100mm flat plate. A German tank commander, examining these specifications, might reasonably conclude that the Hellcat was a death trap, a poorly conceived vehicle that would be destroyed in any direct engagement with German armor. That commander would be technically correct and strategically blind. The Hellcat wasn't designed for direct engagements. It was designed to exploit the one advantage that no amount of German engineering could overcome. The Americans could be everywhere simultaneously because they had enough vehicles to be everywhere simultaneously. The Hellcat's 76mm M1A2 gun could penetrate 88mm of armor at 1,000 yards, sufficient to kill a Panther from the side or rear and a Tiger from the flank. Its Wright R975 radial engine, the same reliable power plant used in the Sherman, generated 400 horsepower, driving a vehicle that weighed one-third what a Sherman weighed, yielding a power-to-weight ratio of 22.6 horsepower per ton. For comparison, the Panther managed 11.5 horsepower per ton. The Tiger I achieved 12.8. These numbers translated into something that German crews found psychologically devastating. They couldn't catch it, couldn't predict where it would appear next, and couldn't effectively retaliate because the Hellcat would be gone before they could bring their superior guns to bear. The production history of the M18 reveals the industrial chasm that separated American manufacturing capability from German production in 1944. Buick, a division of General Motors that had manufactured luxury automobiles in peacetime, retooled its facilities and began producing M18 Hellcats in July 1943. The first production vehicle rolled off the line in January 1944. By June 1944, 6 months after starting production, Buick had delivered 500 Hellcats. By December 1944, when Meyer encountered one in Belgium, 1,500 had been produced. The final production run would total 2,507 vehicles manufactured in 18 months, an average of 139 per month, with peak production exceeding 150 per month. These weren't hand-assembled weapons crafted by specialized technicians. They were mass-produced vehicles built on assembly lines using standardized parts by workers who were predominantly semi-skilled laborers, many of them women who had never worked in manufacturing before the war. Buick's production facility employed 28,000 workers at peak capacity and was producing not just Hellcats but also aircraft engines and ammunition. The entire manufacturing process had been optimized for speed and volume rather than for individual quality, though quality control remained high by the standards of mass production. Germany's tank destroyer production, by contrast, was fragmented across multiple designs and manufacturers, none achieving the production efficiency or numerical output that characterized American manufacturing. The Jagdpanzer IV, Germany's most produced tank destroyer, saw approximately 1,977 units built between 1,943 and 1,945. The Jagdpanther, arguably the finest tank destroyer of the war in terms of firepower and protection, managed only 415 units before the war ended. The Ferdinand, divided by Elephant, a 65-ton monster mounting an 88mm gun, was produced in quantities of 91. Combined German tank destroyer production for all types throughout the entire war totaled perhaps 9,000 vehicles. American production of the M18 alone exceeded 2,500, while the M10 tank destroyer added another 6,706 units, and the M36 contributed 2,324 more. The United States was outproducing Germany in tank destroyers while simultaneously producing more tanks, more artillery, more aircraft, more of everything, because American industry operated with access to unlimited raw materials, uninterrupted power, and workers who weren't being bombed or drafted or starved. German factories were increasingly running on synthetic substitutes, interrupted schedules, and the labor of conscripts and prisoners who had neither the training nor the motivation to achieve the productivity rates that American workers sustained as a matter of routine. The tactical employment of the M18 exploited its speed advantage in ways that German doctrine struggled to counter. American tank destroyer doctrine emphasized mobility, flexibility, and the principle of shoot and scoot, engage the enemy from an advantageous position, fire, and immediately displace before return fire could be effective. The Hellcat was ideal for this role. It could race to a firing position at 55 miles per hour on roads or 35 miles per hour cross-country speeds that allowed it to outrun German armor and even outrun some German armored cars. It could set up, fire its 76mm gun, which had a rate of fire of about 20 rounds per minute with a well-trained crew, and be gone within seconds. German tanks attempting to return fire found themselves shooting at positions the Hellcat had already vacated, while the Hellcat repositioned to attack from a different angle. This wasn't cowardice or poor tactics. It was the exploitation of a technical advantage that rendered German tactical superiority increasingly irrelevant. A Panther might be able to kill a Hellcat in a head-on engagement, but that engagement never occurred because the Hellcat refused to fight on those terms. The Ardennes offensive, Hitler's desperate winter counterattack through the Belgian forests in December 1944, provided the proving ground for this tactical revolution. German armored forces, including Meyer's Panther and hundreds of other tanks including elite Tiger IIs from the newly formed heavy tank battalions, punched through thinly held American lines with initial success, creating panic and confusion in the Allied rear areas. The offensive's success depended on capturing American fuel dumps, because German logistics couldn't sustain the armored spearheads with petroleum products that were increasingly unavailable inside the Reich. As German armored columns raced westward, they encountered American resistance that included M18 Hellcat battalions that had been held in reserve or were being rushed to threatened sectors. What followed was a masterclass in mobile defensive warfare that German armor couldn't effectively counter. Hellcats would appear on German flanks, fire a few shots at vulnerable side armor, and vanish before German tanks could bring their main guns to bear. They would set up ambushes at road junctions, knock out the lead and trail vehicles in a German column to create a traffic jam, then methodically destroy the trapped vehicles from positions that German return fire couldn't reach because the Hellcats had already moved. They operated independently, exploiting the speed that allowed individual crews to make tactical decisions without waiting for higher headquarters, a flexibility that German formations, bound by more rigid command structures, couldn't match. The crew requirements for the M18 reflected American training advantages that compounded the vehicle's technical superiority. A Hellcat crew consisted of 5 men: commander, gunner, loader, driver, and assistant driver. Training for these crews took approximately 16 weeks from induction to deployment, with extensive time devoted to gunnery practice, mechanical maintenance, and tactical employment. American training facilities had sufficient fuel to allow student crews to drive their vehicles for hundreds of hours, learning to handle the Hellcat's exceptional speed and developing the coordination required for high-speed combat maneuvers. They practiced firing on the move, a technique that was extraordinarily difficult, but which the Hellcat's stabilization system and smooth ride made somewhat more feasible than in heavier vehicles. By the time a Hellcat crew reached combat, they had fired hundreds of practice rounds, driven hundreds of miles, and worked together long enough to develop the instant coordination that combat demanded. German tank destroyer crews, by contrast, were receiving increasingly abbreviated training as the war progressed. Fuel shortages meant that driver training was often conducted on horse-drawn vehicles, with actual time in powered vehicles limited to perhaps 20 hours. Ammunition shortages meant that gunnery practice was theoretical rather than practical, with crews learning to aim but rarely firing actual rounds until combat. The M18's maintenance requirements, or rather, the lack thereof, provided another critical advantage in sustained operations. The vehicle used the Wright R975 engine, the same radial aircraft engine that powered the M4 Sherman, and had been in production since the 1932. This engine was stone reliable, tested through hundreds of thousands of operational hours in both aircraft and tanks, and simple enough that crew-level maintenance could address most problems. The transmission was a modified truck transmission, robust and easy to repair. The suspension used torsion bars that rarely failed and could be replaced in field conditions with basic tools. The tracks were single-pin type, easy to repair, and with a service life measured in thousands of miles. This meant that M18s could operate at high tempo without constant mechanical intervention, and when maintenance was needed, it could often be performed by the crew without specialized tools or back-to-workshop requirements. German tank destroyers, particularly those built on Panther chassis, inherited the Panther's chronic mechanical problems, transmissions that failed after 150 kilometers, final drives that broke under stress, complex interleaved road wheels that became packed with mud or snow and froze solid overnight. A German tank destroyer that broke down was often non-recoverable because recovery vehicles couldn't reach it or because repair required specialized parts that were unavailable. An American Hellcat that broke down was usually back in service within hours because the parts were common, the repairs were straightforward, and the supply system could deliver components rapidly. The fuel consumption comparison revealed yet another insurmountable advantage. The M18 Hellcat, weighing 17.7 tons and powered by a 400 horsepower radial engine, consumed approximately 1.5 gallons per mile when driven at high-speed cross-country, or about 0.8 gallons per mile at cruising speeds on roads. This gave it an operational range of 105 miles on its 175-gallon fuel capacity, without refueling adequate for a day's operations with minimal logistical burden. More importantly, American fuel supplies were effectively unlimited. Tanker trucks, carrying aviation gasoline, the Hellcat burned 80-octane avgas. The same fuel used by American aircraft could refuel multiple Hellcats in minutes at forward supply points that were established routinely as American forces advanced. The entire supply chain from Texas oil fields to Belgian forest roads was functioning smoothly, delivering hundreds of thousands of gallons daily to maintain operations. German vehicles, by contrast, were starving for fuel. The Panther consumed approximately 2 gallons per mile, double the Hellcat's consumption to move a vehicle that weighed 2.5 times as much. German fuel production had been devastated by Allied bombing, falling from 181,000 tons in March 1944 to 17,000 tons by September 1944. German armored units in the Ardennes offensive were so fuel-starved that they planned to capture American fuel dumps to continue operations, and when those captures failed, Panther and Tiger tanks were abandoned by their crews because there was no fuel to move them. The crew survival rate in M18 Hellcats was paradoxically better than in more heavily armored vehicles, a counterintuitive result that reflected the vehicle's tactical employment and the nature of armored combat. The thin armor meant that penetrating hits were usually fatal to the vehicle, but the open-top turret allowed rapid crew escape when the vehicle was hit. More significantly, the speed advantage meant that Hellcats were hit less frequently because they spent less time exposed to enemy fire. German gunners found it extraordinarily difficult to lead a target moving at 35–40 miles per hour across broken terrain at ranges of 1,000 to 1,500 meters. The math required to calculate the necessary deflection was complex, and the firing solution changed constantly as the Hellcat maneuvered. By contrast, a German tank moving at 15–20 miles per hour presented a much more predictable target that American gunners could engage with greater confidence. The psychological impact of this speed differential was devastating for German crews. They were accustomed to being the hunters, using superior guns and armor to dominate engagements. Against Hellcats, they became prey, unable to close distance or escape, forced to fight a defensive battle in terrain where their advantages were neutralized. The production cost comparison illustrates the economic gulf that made American numerical superiority inevitable. An M18 Hellcat cost approximately $55,230 to produce in 1944, less than a Sherman tank at $64,000, and a fraction of the cost of American heavy vehicles. This low cost reflected the vehicle's simplicity. Thin armor meant less steel, a proven engine and transmission meant minimal development costs, and straightforward construction techniques meant rapid assembly. For the cost of building one Tiger, a tank estimated at 300,000 Reichsmarks, or roughly $120,000 in 1944 dollars, the United States could build more than 2 Hellcats. But the comparison is misleading because it focuses on unit cost rather than production capacity. The relevant question wasn't, what does it cost to build one, but how many can you build with available resources? American production capacity was so vast that cost became almost irrelevant. The limiting factor wasn't money or resources, but how quickly factories could produce vehicles and how rapidly crews could be trained. German production was constrained by material shortages, labor shortages, disrupted transportation, and systematic bombing of factories and suppliers. Germany couldn't build more tanks because they lacked the steel, the labor, the components, and the fuel to run the factories, not because they lacked the financial resources. The tactical accounts from American Hellcat crews in the Ardennes provide visceral detail about how speed advantage translated into battlefield success. Lieutenant Edwin Leiper, commanding an M18 in the 705th Tank Destroyer Battalion, described an engagement on December 20, 1944. We were positioned near a crossroads when our lead scout reported German armor Panthers moving in column about 2 clicks north. We displaced at speed, maybe 45 miles per hour on that frozen road, and set up a flanking position where the road curved through a depression. When the German column came through, we were positioned on their right flank at about 800 yards. My gunner put 2 rounds into the lead. Panther both penetrated the side armor. The second Panther tried to traverse its turret toward us, but we were already moving, racing to a secondary position we'd identified earlier. The Germans fired at where we'd been. We fired at where they were. By the time they'd repositioned to engage our new location, we'd killed 3 Panthers and were displacing again. They never got a shot at us. Speed was everything. The comparison between German and American tactical flexibility reveals another dimension of the Hellcat's superiority. German armored doctrine in 1944 was defensive and reactive, shaped by years of fighting the Soviets on the Eastern Front, where battles were often attritional slugfests decided by who could absorb more losses. German tank commanders were trained to select strong defensive positions, use their superior guns and armor to engage at long range, and hold ground. This doctrine made sense when you possessed the best tanks in the world and faced enemies with inferior equipment. It became suicidal when facing enemies who refused to attack on those terms and who could afford to trade vehicles at ratios that looked favorable to German commanders but were actually destroying German armor faster than it could be replaced. An exchange rate of 3 Hellcats for 1 Panther sounds favorable to Germany, until you realize that America was producing 10 Hellcats for every Panther Germany built, making the exchange rate strategically disastrous for Germany, regardless of the tactical optics. The M18's crew ergonomics reflected American attention to human factors that German designs often neglected in favor of technical performance. The open-top turret provided excellent visibility for the commander and superior ventilation that reduced crew fatigue on long operations. The fighting compartment was spacious by tank destroyer standards, allowing the crew to work efficiently without the cramped conditions that characterized German vehicles. The gun controls were smoothly geared and easy to operate, allowing rapid target engagement. The driver's position was comfortable with good visibility through periscopes that provided a wide field of view. These seem like minor considerations, but they accumulated into significant combat advantages. A crew that wasn't exhausted, wasn't breathing cordite fumes, and could see clearly was more effective in combat. The contrast with German vehicles was stark. Panthers had notoriously cramped interiors, poor visibility for the driver, and complex controls that required significant training to master. A Panther crew finishing a long approach march was tired and stressed before combat even began. A Hellcat crew could cover the same distance faster and arrive fresher, ready to fight immediately. The strategic bombing campaign's impact on German armor production was devastating and multifaceted. Direct bombing of tank factories was only part of the story. More significant was the destruction of component suppliers, transportation networks, and the entire industrial ecosystem that supported armor production. A factory building Panthers might survive a bombing raid intact, but if the supplier of final drive assemblies was destroyed, Panther production stopped anyway. If the rail network couldn't deliver completed tanks to combat units, then production numbers became meaningless. There were hundreds of German tanks sitting at factories in late 1944 and early 1945 that never reached combat because transportation was impossible. The dispersal of production into smaller facilities to avoid bombing degraded efficiency and quality control. Workers spent time in air raid shelters rather than on production lines. Quality suffered, as experienced workers were drafted and replaced by forced laborers or hastily trained substitutes. The entire system was collapsing not because any single component failed, but because every component was degraded simultaneously, creating compounding failures that rendered German production increasingly ineffective, even when nominal output numbers remained respectable. The Hellcat's operational deployment demonstrated American advantages in logistics and command flexibility that German forces couldn't match. Tank destroyer battalions were independent units attached to infantry or armored divisions as needed, providing flexible fire support that could be concentrated where required. This organizational structure allowed American commanders to mass Hellcats at threatened points or to distribute them broadly across a front, depending on tactical requirements. Communication networks were robust, with radio equipment standardized across units and working reliably in all conditions. Supply was predictable. Crews could count on fuel, ammunition, and spare parts being available when needed because the supply system functioned with industrial reliability. German armored units, by contrast, were often fighting blind, with degraded communications, uncertain supply, and command structures that were rigid and slow to respond to changing conditions. A German Panther unit that encountered unexpected resistance couldn't call for reinforcement or supplies with any confidence they would arrive. A Hellcat unit in similar circumstances could have additional tank destroyers, infantry support, and air cover on site within hours. The psychological dimension of fighting Hellcats was particularly corrosive for German morale. German tankers had spent years developing professional confidence based on superior equipment and training. They knew their Panthers and Tigers were better armed and better armored than anything the Allies fielded, and this knowledge provided psychological armor that sustained them through difficult combat. The Hellcat undermined this confidence by simply refusing to engage on terms that favored German armor. German crews found themselves in the disorienting position of being technically superior but tactically helpless, possessing better guns they couldn't bring to bear, and better armor that provided no protection against threats they couldn't see until too late. The frustration of watching an enemy vehicle appear, fire, and vanish before you could react, repeated across dozens of engagements, created a sense of futility that no amount of pep talks or ideology could overcome. German tank commanders were calculating survival odds and arriving at conclusions that made continued resistance seem pointless. The winter conditions in the Ardennes actually favored the Hellcat, despite seeming like they should favor the heavier German vehicles. The frozen ground provided firm surfaces, where the Hellcat's lighter ground pressure and superior power-to-weight ratio allowed speeds that heavier vehicles couldn't match. Panthers and Tigers, pressing down with enormous weight per square inch on their tracks, broke through frozen surfaces into mud beneath, creating traction problems that the lighter Hellcat avoided. The Hellcat's radial engine started reliably in cold weather. American engine design had been tested in Alaskan conditions and performed well in extreme cold. German engines, particularly the Panther's Maybach 512, required extensive warming procedures in cold weather and were prone to failure if not properly maintained. The open-topped Hellcat turret, which seemed like a liability in winter, actually allowed snow and moisture to escape rather than accumulating inside the crew compartment, and the crew wore cold-weather gear that was adequate for the conditions. German crews in enclosed vehicles dealt with condensation, ice forming on internal surfaces, and vision devices that fogged or froze, degrading combat effectiveness. By January 1945, as the Ardennes offensive collapsed and German armored forces retreated, the evidence of the Hellcat's effectiveness was visible across the battlefield. Dozens of destroyed Panthers and Tigers dotted the landscape, many killed by flank or rear shots characteristic of Hellcat tactics. German after-action reports from surviving units repeatedly mentioned the speed and maneuverability of American tank destroyers as a critical problem. One report from 1st SS Panzer Division, recovered from German archives, noted, "The American tank destroyer forces demonstrate extraordinary mobility that allows them to concentrate rapidly against our advances or to escape when attacked. Our attempts to engage them in decisive combat have been consistently frustrated by their refusal to remain in position once detected. Proposed tactical responses have proven ineffective due to our limited mobility and increasingly severe fuel constraints. Losses to these units are significant, and replacements are not available. The philosophical difference between German and American approaches to armored warfare reached its culmination in the Hellcat program. Germany pursued the Wunderwaffe, the wonder weapon, believing that technological superiority could compensate for numerical inferiority. They designed and built tanks that were individually superior to anything the Allies fielded. The Tiger II, introduced in late 1944, was probably the most formidable tank of World War II, with frontal armor that no Allied tank gun could penetrate at combat ranges, and an 88mm gun that could destroy any Allied vehicle. Germany built 489 of them before the war ended. They were mechanical marvels and tactical dead ends, magnificent weapons that had no strategic impact because 489 Tiger IIs couldn't be everywhere, couldn't sustain operations without massive logistical support that didn't exist, and were being destroyed or abandoned faster than they could influence the overall military situation. The Americans, by contrast, built adequate weapons in overwhelming numbers. The Hellcat wasn't the best tank destroyer that could theoretically be built. It was the best tank destroyer that could be built in the thousands with available resources and deployed by crews who could be trained in reasonable timeframes and sustained in combat operations for extended periods. The production numbers tell the final story with crushing clarity. From 1,943 to 1,945, the United States produced approximately 88,000 tanks of all types, 42,000 of which were M4 Shermans. They produced more than 10,000 tank destroyers, including 2,507 M18 Hellcats. They also produced 324,000 artillery pieces, 2.4 million trucks and jeeps, 297,000 aircraft, and millions of tons of ammunition, fuel, and supplies. Germany, over the same period, produced approximately 25,000 tanks, 9,000 tank destroyers, 159,000 artillery pieces, and 120,000 aircraft. These aren't trivial differences. They represent an industrial disparity so vast that no amount of tactical brilliance or technical sophistication could overcome it. The United States was outproducing Germany by ratios ranging from 2-to-1 to 4-to-1 depending on the weapon system, while simultaneously supporting the Soviet Union through Lend-Lease, supplying Britain, and maintaining a war in the Pacific that required its own enormous allocation of resources. American industry operated at this tempo while the civilian economy continued functioning, with consumer goods still being produced and living standards maintained. German industry was operating under conditions of total war mobilization, with every resource allocated to military production, and still couldn't match Allied output. The crew accounts from the final months of the war paint a picture of complete German collapse. Oberscharführer Meyer, whose Panther had been unable to track that racing Hellcat in December, survived the Ardennes offensive, but his unit was destroyed piecemeal in the retreat. His diary, captured when he was taken prisoner in March 1945, contains an entry from February 14th. Saw 3 American tank destroyers today. Tried to engage, but they were moving too fast for accurate fire at range. When we attempted to close distance, they withdrew at speeds we cannot match. Fuel situation is critical. We have perhaps 50 kilometers of operating range remaining. Ammunition short. No replacements available. We are not fighting a war anymore. We are waiting to die or be captured. The Americans have already won. They won before the Ardennes even began. We just didn't realize it yet. That realization that the war was decided by production capacity rather than battlefield prowess came too late for Meyer and thousands of German tankers like him. They had been fighting with equipment that was technically superior while being strategically obsolete, victims of a strategic miscalculation that had been made years earlier when Germany chose to pursue territorial conquest without securing the industrial base necessary to sustain modern warfare against industrialized opponents. The Hellcat wasn't just faster than German tanks. It represented a system of production, training, logistics, and tactical employment that Germany couldn't match. The speed was the visible manifestation of this systemic superiority, but the real advantage was measured in factories working 3 shifts, training programs graduating thousands of crews, supply columns delivering fuel and ammunition without interruption, and an economy that could sustain warfare indefinitely because it was fighting with industrial surplus rather than strained resources. The lesson of the Hellcat transcends the specific details of its design or deployment. It demonstrates that in industrial-age warfare between peer competitors, victory goes not to those with the best individual weapon systems, but to those with superior production capacity and logistical sustainability. The German tankers who watched Hellcats race across battlefields at impossible speeds were witnessing the physical manifestation of America's industrial dominance. Those Hellcats weren't just fast. They were numerous, reliable, well-supplied, and crewed by trained soldiers who would be replaced if killed because the training system produced replacements continuously. They operated as part of a military machine that functioned with industrial efficiency, where every component from ammunition production to crew training to battlefield tactics had been optimized not for individual excellence, but for system performance. Germany had built beautiful, sophisticated weapons that were defeating themselves by demanding resources Germany didn't have. America had built adequate weapons in overwhelming numbers, supported by logistics that never failed, operated by crews who were good enough, and deployed according to doctrine that exploited advantages rather than pursuing perfection. In the end, the story of German tankers discovering that American Hellcats could reach 55 miles per hour is really the story of discovering that they were fighting an enemy who had already solved a different problem, not how to build the best tank, but how to win a war. The speed was shocking because it violated every assumption German doctrine had made about armored warfare. But the real shock should have been the production numbers, the logistics capabilities, the training systems, and the industrial ecosystem that could sustain high-tempo operations for years without degradation. Meyer couldn't catch the Hellcat he saw in December 1944, but that was the least of his problems. The real problem was that there were 2,500 Hellcats, and thousands of Shermans, and tens of thousands of other vehicles, all supported by an industrial base that was still expanding while Germany's was collapsing. The race wasn't between a Panther and a Hellcat. It was between two economic systems, and that race had been decided in Detroit and Pittsburgh and Cleveland, in factories that built adequate weapons faster than Germany could destroy them. The 55 miles per hour was just the most visible proof of a truth that German commanders had been desperately trying to ignore. They were being buried under an avalanche of American industrial output, and no amount of technical sophistication or tactical skill could change that fundamental reality.